Hello everyone and welcome to this my video on sampling without replacement, part of the probability section for mathematical methods units 1 and 2. Now don't worry about it if you have no idea what mathematical methods is. Sampling without replacement is universal maths and hopefully this video will be good. My name is Darren from Maths Guru. I think I said that before below. Yes, and basically I'm recording videos that hopefully make maths make sense really and help you smash whatever course you are currently doing. Behind me are our learning objectives. And it says to understand what it means to sample without replacement, understand the effect this has on a probability distribution, and understand what it means to be a hypergeometric distribution. So much language, but so much easy. Now, this is building on a previous lesson we have done. And again, all of these lessons are available on mathsguru.com, totally free to sign up, where there are CAA exam questions. There are all of these videos, downloadable lesson notes, and much more to come. And I promise you, it is awesome. I would say that. I'm recording it. Anyway, it's going to be a really short chapter because it's building on what we've done previously. It's also realistically a recap of the work in years 9 and years 10 on basic probability. Now, realistically speaking, we tend to take things out of a pack, or we take sweets out of a bag, or we do all these type of things, but we always seem to put them back, which, to be honest with you, is gross. I mean, I don't want my cola cubes to be coated in someone else's fingers. Do you know how many people don't wash their hands when they go to the bathroom? Ooh, too much. Anyway, you're going to say, what is a cola cube? A cola cube is a sugary, and more sugar dessert. It basically rips the top of your teeth or your mouth off. But if you haven't had a cola cube, try and find them, which is weird because I've never had a violet crumble before. But now someone's very kindly bought me some violet crumbles and I'm going to give it a go today. Right, enough of that rubbish. Have you subscribed to my YouTube channel? What do you mean there's more rubbish? I know, but you're the only people who watch my videos. If you can subscribe to YouTube, and that basically just sends me messages and say, yeah, I watched your video. Keep going. Keep talking to yourself. Now, what happens if you don't replace them and that cola cube, it goes? Well, we're not going to deal with cola cubes because no one knows what they are. We're going to deal with mints and toffees. And in a jar, I've got 3 mints and 4 toffees, which probably means I've eaten all the others. Anyway. I'm going to select 2 sweets. Without looking, I can't cheat, and I want to see how many mints I'm going to get. Now, that's our random variable x, and if you don't understand what I mean by that, basically go back to the previous video. But we're going to create something that says we're looking for how many mints I'm going to get. Now, obviously, it is clear that if I'm going to pick 2 out, then I'm either going to get no mints, I'm going to get 1 mint, or I'm going to get 2 mints, right? And again, I've got to be clear here that I'm not going to replace the sweet once it's taken. So what is it going to do to my probabilities? Well, in this situation, probably the best way to do this is to draw some sort of tree diagram, because I'm going to end up with mint or a toffee as one of the choices. And again, a mint or a toffee, a mint or a toffee. Now, the first time we pull this out, how many mints are there? There are 3 mints. So that's going to have a probability of 3 on 7, because initially there are 7 sweets in there, 3 of which are mints, which would suggest that 4 of those out of 7 are toffee. And again, if you remember with tree diagrams, they have to add up. The outcomes on this branch must add up to 1. Now, again, for a VCAA exam question, or in fact for any question that your teachers may give you, you are always advised to write the outcome and the distinct probability on each of these branches, okay? It's going to make life a little bit easier. Now, this is where people get tripped over. I have now taken one of those mints away and I'm not replacing it. So the chances of me now getting a mint is, well, there's only 2 mints left, but in fact, out of 6. Why is it out of 6? Because I'm not putting that sweet back. Well, this would suggest there is now 4 out of 6 here. Again, I've got toffees, 4 out of 7 toffees. Now, again, I can go down here and probably do this one first, which is 3 out of 6, which would give this 3 out of 6 as well. That's my tree diagram done. And what can I actually do now is I could go and sort of complete this off and say, well, we've now got, this is a mint followed by a mint followed by a toffee followed by a mint, and a toffee followed by a toffee. And how would I work out each of those probabilities? Well, I would simply multiply each of these together. Now, again, for a VCAA exam question, or more likely for your Year 11 exam, you would want to be showing your outcomes and your probabilities. So here I'd probably be putting that's going to be 3/7 times, well, 2/6 is 1/3. So I'm going to cancel those through, which gives me 1 on 7. So the probability of getting a mint followed by a mint is 1 on 7, and I could continue that through. But good news, I've pretty much got that there. All right, so looking at my probabilities now, 4/7 times 3/6. 4/7 times 3/6. Well, we've said that that's equal to 1/2, I think I said. Let's just go back to that one. Yeah, mint, mint. Yeah, because this diagram's the other way around. It's toffee, toffee. So 4/7 times 4/7 times 1/2. Well, 2's go into there 2 times. That's going to be 2/7. What I've got here, 4/7 times 3/6. Well, 3/6 is also a half. That goes into there 2 times. So that's going to be 2 on 7. Toffee is going to be 3/7 times 4/6, which is 2/3. That's going to cancel to give me 2/7. And again, mint followed by mint, 3/7 times 1/3 gives me 1/7. Now, what do we need to do? Again, whenever I do this, a very quick check to make sure I don't then ripple through mistakes is to ensure that all of these 3 probabilities at the end adds to make 1, because those are exhaustive. So 2, 4, 6, 7, I'm pretty happy with how that goes. Now, that means we can now put this information into my probability distribution. Again, x equals x, if you remember, that notation simply means we've chosen our discrete random variable as the number of mints, and we've got 0 mints, 1 mint, or 2 mints. Where did they come from? Well, again, we now go back again to the number of, there are no mints, right? That must have means they got 2 toffees. That's 2/7. Ah, there's my 2/7. Where did the 4/7 come from? Well, if there was 1 toffee there and 1 toffee there, we would want to add those 2 together, which gives me 2/7 plus 2/7 is 4/7, and there is 1/7. And again, remember, for a probability distribution, they must add to be 1. Now, the question is, while that was easy, we're taking 2 mints. What if I filled that up and was choosing 14 different sweets out? It would be absolutely impractical to try and work out, sort of with a tree diagram, how to do that. So there must be another way. And this builds on the combinatorics videos that would have come up previously in this series, or at least on mathsguru.com. Because what we can now do is use combinations stuff to find each of these individual probabilities. So the number of ways of getting 2 toffees and no mints. If I have got 2 things I'm choosing from, I am looking for 2 toffees and 0 mints. Well, the first thing is, how many toffees were there? There were 4. So I've got 4 toffees, and I'm going to choose 2 of them. So there's my toffees, and there's my mints. Now, again, we can use this because the order isn't important. All right, so because the order isn't important, I can do how many ways are there of choosing 2 out of 4, and mints, well, there were 3 mints, choose 0. Now, again, if you want to remember how to do that, we can fire up my TI Inspire. Cassia, I'm fairly sure you've got something fairly similar. I'm hit menu, calculator. If I go menu, statistics, no, probability. It's on one of these. Come on. Ah, there you go. Combinations. Now it goes NCR, not particularly helpful in terms of notation, but what we can do now is do 4,2, hit enter, and that comes out to be 6 times. I know that 3C0, anything that 3C0 is basically equal to 1, because that's the end of Pascal's triangle. So that's going to say that there are 6 ways of choosing 4 toffees and 3, but we want a probability, don't we? So we've got to try and work out now, well, what were the total number of ways of choosing 2 sweets from all of them? All right, and that's basically shown here by 7 choose 2. So again, if I fire up my calculator, I'm just going to copy that down, change that to a 7, hit 2, is 21. So there are 21 ways of choosing 2 sweets out of the 7 that we have. It was 7. Yes, 7. All right, so therefore, we now know that this probability here is going to be 6 on 21. Cancel that down, gives me 3. Nope. 3 is going to that 2. 3 is going to that 7. There's my 2/7. There's my 2/7. Yes. Number of ways of getting 1 toffee and 1 mint. So we're now saying there's my number of toffees, there's my number of mints. So 4 toffees and I'm choosing 1. 3 mints and I'm choosing 1. Well, 4 choose 1 is 4. 3 choose 1 is 3. That gives me 12. So this one here is going to be 12 on 21, which if we put, what do we put, 3's into that? It gives me 4 on 7. Aha, we're good. And what does it have now? No toffees and 1 mint, oh sorry, 2 mints. So 4 choose 0 and 3 choose 2, which is going to give me 4 choose 0 is 1 and 3 choose 2. Did I already work that one out? Nope. So again, I'm just firing up my calculator, copy that up, and I'll just do 3 choose 2. We can probably work out that's going to be 3 anyway. And so that's going to be 3 on 21, which is 1 on 7. And there we go. So that's another way of being able to do that with the combinatoric stuff that we've done previously. All right. Now, what is a hypergeometric distribution? Basically, it just means that we are selecting without replacement. I know. Why couldn't we just say selecting without replacement? But we love long words in mathematics, do we not? Right. Let's look at a quick example, and I say this video is almost done. Marine biologists are studying a group of dolphins which live in a small bay. Bless. They know there are 12 dolphins in the group. That's going to become significant. 4 of which have been caught, tagged, and released to mix back into the population. If the researchers return the following week and catch another group of 3 dolphins, what is the probability that 2 of these will be tagged? So we got the idea that we got tagged and we got not tagged. So tagged, we know that there are 4, there are how many dolphins? 4 have been caught, right? So 4 have been tagged, which would suggest 8 have not been tagged, right? We are choosing 3 dolphins. So we know the total number of choosing 3 dolphins out of the 12 is 12 choose 3. Okay. So 4 of the dolphins have been tagged, but we want to work out what is the probability that 2 of them will be tagged. So out of the 4, what is the probability we get 2, or how many different ways are there of getting us 2 of those 4, which means we would have to have one of those. And again, it's interesting to note that that 4 plus 8 gives me the 12, and 2 plus 1 give me the 3. Let's fire this up, and let's see what we've got. Division sign, so I'm going to do NCR, 4, 2. Let's times that by NCR. And we got NCR of 12,3. Oh, now obviously we've got a bit of a problem here. Why? Because my calculator seemingly has remembered my previous setting to be approximate. And because methods should always be an exact, let's do that one again. And so we get our answer of 12 on 55. And there we go, pretty much. That is the end of the video. You've just got to basically put the stuff from previous work and probability stuff together. Right, understand what it means to sample without replacement, tick. Understand what effect this has on a probability distribution, tick. Understand what it means to be a hypergeometric distribution, and we've applied it to some questions. If you can subscribe to my YouTube channel, awesome. If you want to head over to Maths Guru and sign up for free, there are all these videos and bits and pieces on there. And hopefully I'll see you in another video. Spread the word if you can. Otherwise, hopefully I'll see you soon. Take care, guys. Bye-bye.